Hello and welcome to the CenterLine Windsor Limited webinar. My name is Rich North, your host from IHS Global Spec. I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading CenterLine Windsor Limited Presentation in the upper left is the primary window for today's webinar. You should be seeing the welcome slide there right now. Just to the right of the main presentation window is the speaker bio window with background information on today's presenter, Ed Mallison. Now just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the Q&A window and click Submit. Your question will then be placed in the queue for the speakers to address when we get to the Q&A session. Now if you look to the bottom of your screen, you'll see 9 buttons. The first 3 either minimize or restore the 3 windows we've already talked about. The others allow you to share this webinar with colleagues, access presentation resources, contact us, take a survey, and lastly do a little troubleshooting like running the system test or consulting the FAQ document. The button second from the right is the volume control for the webinar, but it is probably best to leave that button alone and adjust your volume using the controls you are familiar with on your own system. If you can't remember what a particular button does, just hover your mouse pointer over it and a tooltip will appear with a description of the button's function. And now to get this webinar started, here's Mark Levesque.
Hello everyone, my name is Mark Levesque and I'm the Director of Corporate Marketing for CenterLine Windsor Limited. Before we get started today, I'd like to provide a bit of an overview on our company. CenterLine's been in business since 1957. We currently employ over 600 people, have locations throughout North America, South America, Europe, and India. We are primarily involved in the manufacture and supply of systems and products primarily aimed at resistance welding and other metal joining applications. About 10 years ago, the company diversified by creating Supersonic Spray Technologies division. That division is currently involved in producing manual and robotic equipment and system offerings in support of cold spray technology. In today's webinar, we're going to describe that technology in a little bit more detail and show you where it's being used today to remanufacture high-value components. Now it gives me great pleasure to introduce today's speaker. Mr. Ed Mallison is the Director of Business Development for SST Division. Ed is a certified NACE coatings inspector. He has a Bachelor of Science degree from the University of Toronto in physics and chemistry and has over 25 years experience in industrial coatings. Without further ado, here's Mr. Ed Mallison.
Thank you for that wonderful introduction, Mark, and thank you for all the preparation that you provided in producing this webinar this afternoon. My name is Ed Mallison. I'd like to welcome each of you to today's webinar titled Cold Spray Metal Coatings, a practical repair tool for the remanufacturing industry. Now, before we get into the formal definition of cold spray, I want you to imagine something for a second here. Imagine a control unit about the size of a 2-drawer filing cabinet with wheels on it. So it's portable, you can move it around. Also imagine something about the size of a hairdryer, handheld hairdryer, with a 1/4-inch exit nozzle. Now connecting these two is a 1-inch diameter flexible conduit. Imagine coming out of the end of that 1/4-inch nozzle metal particles traveling between 300 and 700 meters per second directed towards a target. The target is either a metal or glass. You're going to make a coating on that substrate. That's basically what cold spray is. Cold spray is a metal coating technology. It's not thermal spray. There's no heat or masking required. You're going to use metal powders to form the coating. There's no special skills or certifications required to apply coatings, and I'm going to show you the equipment in pretty good detail. And it's primarily aimed for high-value components requiring localized repair. And for you that are in the remanufacturing business, this is perfect for you. Here at CenterLine, we design, manufacture, and sell a wide variety of practical cold spray equipment. You can apply cold spray with either a manual or robotic gun. Using low heat, it preserves the original mechanical properties of your component. These coatings are quite dense, there's low porosity, and they're quite machinable. The coatings can be engineered for a wide variety of purposes: wear and corrosion resistance, for conductivity applications, etc. Cold spray has a much lower environmental impact than thermal spray, and powder design is critical. Here at CenterLine, we also design and manufacture powders to go with your cold spray equipment. Now, as promised early in this webinar, I'm going to show you exactly what you need to install cold spray capabilities into your operations. So let's start with the manual systems. You remember I asked you to imagine a handheld spray gun. Well, there it is on top of the blue control system. So you need a manual spray gun, a control system for spraying, which is the blue colored cabinet, a powder feed system, some basic personal protection equipment, and your valuable part that requires remanufacturing. I want to mention something here at this time that's quite important. A lot of the remanufacturing application requests that we come across have to do with a customer who maybe over-machined a certain component. In order to recover that component, especially where he's got quite a bit of value added into the part, he'll cold spray an excess of material, put it on the same CNC machine from which it was originally machined, and then machine it back to original specification. Now, what I'm showing you here is an SST robotic system. Again, it starts with the control system located inside the blue cabinet. You can see a black flexible hose leaving that cabinet traveling to the end of the robotic arm. Attached to that robotic arm is a SST Series EP gun. The entire unit fits in a environmentally controlled spray booth. And finally, one of the systems I'm showing you here is an SST cabinet system. Again, you're going to require a manual or robotic spray gun. In this particular case, this cabinet unit's been fit with both a manual and an automatic robotic spray gun. Starting at the left of this image, you can see our familiar control system located inside the blue cabinet. Right above that blue cabinet is actually a control system for the robotic gantry unit to the right side of the cabinet. On the left side of the cabinet, we have the capability to spray manually. Moving further to the right, you can see a wet scrub air filtration system. To the right of that scrubber, we have an external pressurized volumetric powder feeder. And in between the cabinet and the wet scrubber is our gas supply purification unit. Now, one of the objectives of our webinar this afternoon was to introduce you to some case histories as early as possible. Let's start with our first case study here. It's a manual SST application. What we have is a very large engine block made out of cast iron. The mounting pads are out of height due to a machining error. The repair involved here could not tolerate any excessive heat. We didn't want to affect the tolerances of the mounting pad or surrounding areas of the block. This is an example of a SST field service where we actually put one of our SST technicians at the customer's site. So it was an on-site repair. The application went very well. You can see the three-hole engine mount there has a fair amount of nickel coating applied to it. The customer would just put this back through his normal operations and finish it to his correct tolerance. Now, moving right along, we're into our second case study. Again, it's a manual application. We have some worn bearing seats. Of note here is that there's a ring groove inside these bearing seats as well. Previously, the customer really had no repair process to salvage these parts. We introduced them to cold spray. There was no masking required to complete these repairs, and definitely no excessive heat introduced to the part. Customer reported back to us that there was about $75,000 worth of housing saved in the first month of use. Again, the customer would simply mount the cold sprayed part into his CNC operation and finish it to his final tolerances. Okay, so you've seen a couple of examples, some case studies where we've shown you some SST cold spray application. Of course, the question becomes, when do I know that cold spray is the right repair solution? So when do you choose cold spray? You choose cold spray when the coating area is not overly large. You want to preserve or improve some original material properties. If you're currently using any repair processes that incur excessive masking or setup costs, you will want to consider using cold spray. If your substrate is sensitive to heat, in other words, it distorts, or you're working with very thin metal materials that can't accommodate any heat processes, you will consider using cold spray as a repair tool. So let's say that you're now thinking about some of the applications in your own operations. You want to consider calling me and discussing your repair concerns. What is there to consider here? Well, we'll talk about the size and extent of the repair. We will discuss the substrate that you're trying to repair and the coating material itself, remembering these two materials don't have to be perfectly matched. As an example, we can repair a lot of magnesium components using aluminum, or we can repair cast iron blocks using nickel-based coatings. What is the objective of your repair? What are you trying to accomplish here? Obviously, you want to salvage a component to its original specification, and obviously you want to maximize the resale value or usable value within your operation. And what are you expecting after the repair? Can you provide us with your performance specifications? Those are very helpful in designing a correct solution. Now, putting ourselves in your place, what other considerations are there? Well, you want to compare the cold spray cost versus other repair processes. Obviously, you want to compare the cold spray cost versus part replacement, and that's where the value of the part becomes quite important. The turnaround time to repair versus the time to manufacture a new part and the costs associated with that. And any post-repair considerations. Is it machinable? What's the appearance? Are there metallurgical concerns? Are there mechanical concerns? You can discuss any of these concerns with us. Now, CenterLine has the capabilities of helping you verify or validate the cold spray success criteria. Here's a typical process analysis that we would go through. We're going to carefully examine your component and determine the following. Can the substrate material be cold sprayed at all? Now, so long as the material has enough integrity to accommodate the high velocity metal particles, in most cases the surface will be cold sprayable. And these include metals, glass, and ceramics. Can the wear damaged component be repaired? Is it accessible? What's the size of the repair area? How much coating is needed? Can the part be mounted, rotated to the proper orientation? We'll look at the costs, and we will examine the fitness of the remanufactured part and compare it to original specifications. Again, CenterLine has the capabilities to help you validate your application repair. Let's review a recent example where an existing customer came to us with a new application. It involved his desire to repair for resale some worn aluminum G-rotor components. And looking at the image here, you can see the wear that was incurred on the impeller side of the G-rotor. Customer said that the repair must meet these following requirements. The coating has to be corrosion resistant, erosion resistant, and wear resistant. And for those of you who know how G-rotors operate, you can see why those three requirements would have to be met. Oil is going to be the fluid that's pumped through the mechanism. Obviously, the coating must have excellent adhesion, and it has to work with CenterLine's SST Series P equipment, which the customer already owns. We worked carefully with the customer looking at the application, and what we recommended was our SST AO50 aluminum powder, operating at a gun pressure of 250 psi, 400 degrees Celsius. Again, we're drawing from a huge database of experience where over the past 10 years we've collected information and using our own job shop data have the ability to create solutions based on customer requirements. Let's use another example of a cold spray validation process. We had a new customer contact us, and he wanted to repair an underwater valve housing. Typically, he's using underwater divers equipped with marine welding technology. The valve here was made of cast iron and it was coated with marine epoxy. There was leakage from the valve housing, but not at any particular flange interface. Customer wanted to compare cold spray application to his current underwater welding solution, and this valve could not be removed, repaired, and placed back into service. It had to be repaired in situ. This was a fairly easy application to evaluate. Cold spray equipment, any cold spray equipment, will not work in an underwater environment, and it was quickly rejected. It was recommended that the customer work with his current solution provider. What I'd like to do now is give you the third example of a cold spray validation process. This comes from an existing customer of ours. Just below the sleeve of this diesel engine block, there was a shelf upon which the sleeve was resting, and in that area there was some corrosion, severe enough that it would interfere with the function of the cylinder. I want to make note here that we're not lining the actual cylinder surface itself, but just the area below the bottom end of the cylinder on that actual shelf. So here are the factors that our customer asked us to consider. Obviously, it has to be corrosion resistant. It's going to experience relatively high heat. These blocks are put through a caustic wash system, so the coating would have to survive sodium hydroxide wash. We have to get inside a bore ID of 5 inches. Obviously, in this environment, we need excellent adhesion to the substrate, and the powder would need to work with our SST Series P equipment, which they already own. So what we recommended in this particular case is use of our SST N0063 at the maximum pressure of the Series P gun, which is 250 psi, and the upper temperature limit of the manual gun, 500 degrees C, and a right angle nozzle system. I wanted to make mention that we introduced a new modular nozzle system late last year. There's a picture there of a 90-degree modular nozzle system with a short 70-millimeter nozzle. These new SST modular nozzle systems will fit any existing SST equipment. They were designed for extreme ease of use, highly extended service life, and efficient non-clogging flow of metal powders. So I previously mentioned that CenterLine can assist you in validating your repair process. How exactly do we do that? We do have process development and validation capabilities. We can, in our own job shop, coat some sample parts for you and conduct some coating testing. The SST job shop located in Windsor, Ontario, just outside of Detroit, has experienced and trained SST technicians with all cold spray equipment at our disposal. Here's an example of a customer who had actually misdesigned a cam cover. Originally, it only had 2 points upon which to fasten to the block. The connection was not intimate enough to prevent any oil leakage. For him to redesign, remanufacture these cam covers would have taken months to accomplish. He approached us and asked us if we could actually cold spray material to allow him to machine a third point of contact, a third boss. We did this very quickly. The customer used his own machining capabilities, tested the 3-point cam cover where it passed immediately. Again, these are some of the coding and mechanical experience that we can share with our customers. So we're working up towards a cost evaluation, and let's look at some direct cost considerations. You've got the equipment capital cost. You've got some peripheral system costs such as ventilation, booth, powder feeders, air purification. You've got some consumables here that are actually used during repair processes, and those obviously include the raw material metal powder, propellant gas, nozzles, electricity, any masking if at all required. We'll take into consideration surface preparation technologies, manpower, and we'll also evaluate any post-repair machining finishing costs as well. Now, by working closely with you, we can uncover even more cost savings by comparing our cold spray process to your current repair process or scrap economics. We're going to look at your turnaround time, the extendable life of the part, any costs associated with reduced environmental impact, substitution prevention, and any in-house process savings, such as no need to ship your parts to a third-party vendor, any packaging considerations, any markups, and overall time savings within your operations. I wanted to show you just one example from literally hundreds of technical evaluations we've done over the past decade. And if you have a particular component or part that you're interested in evaluating, we may already have it within our database, or we can develop that data for you. So let's go through this particular example here. We've got a magnesium casting repair. We're going to use our SST Series P at 250 psi gas pressure. We're going to use a stainless steel nozzle assembly with a 2.5 millimeter orifice, and the nozzle is 120 millimeters long. The feedstock here, the powder, is SST's A050. The substrate's a magnesium plate and it's attached to a gearbox housing. We're going to have our robotics cover an area approximately 25 millimeters by 86 millimeters. So what we wound up with were spray conditions of the following: a gun temperature of 400 degrees C, air pressure of 110 psi. That's important to note because that's just your standard shop compressed air. Number of passes to accomplish this deposition was 23. We're going to record our powder feeder rate at 12 RPM. We're going to step over the robotic pathway at 1.2 millimeters, considering that the nozzle exit diameter is approximately 6.1 millimeters. Our robotic travel speed is 20 millimeters per second. The coating thickness is around 10 millimeters. And the standoff distance, that is the distance between the end of the nozzle tube and your substrate, is between 10 and 15 millimeters. It's important to note that the standoff distance isn't critical to maintain a specific tolerance. That standoff distance can fluctuate actually quite a bit due to the true particle trajectories exiting the nozzle. So, if you're considering cold spraying your component, let's go through an actual cost calculation. Customer approached us, wanted to look at a different repair process for his turbine blade roots. The material here is SST A050 aluminum powder. We made some assumptions on how many parts per shift the customer could accomplish using SST cold spray equipment. Here's what we determined. Raw material cost of 18 cents. The propellant gas here is nitrogen, approximately 4 cents. Electricity, 1 cent. Labor, we made some assumptions again on how many parts per hour and the hourly wage, calculated to about $1.51 per part. Consumables, 11 cents per part. Setup, we used 500 parts per setup, winding up with 7 cents per part. Amortization at $1.41 per part for a total cost of $3.33 to cold spray repair this part. Now here at CenterLine, we design and manufacture powder and powder blends to be used with our SST equipment. We have a vast technical database, over 200 powder blends. You've heard me mention the SST A0050 in the past. I'm just using this as an example to show you how we describe our powders in a technical data sheet. We're going to describe the material properties of the powder. We're going to describe the typical coating properties that you see as a result of spraying the cold spray powder through our equipment. And in each case, we're going to describe the recommended spray parameters. Now, as we expand our equipment offering, we'll expand the recommended spray parameters to accommodate all of our equipment being sold. There is a military specification developed around cold spray. Let me give you that standard number right now. It's MIL-3021, and CenterLine was instrumental in contributing to that military standard. In addition to that, many of our customers are writing some of their own specifications. Here's just one example where we helped a customer develop an internal specification on the repair of an aluminum-based support bracket for the Boeing 737. Now, within the service letter, I've expanded the areas where you can see where the approved cold spray equipment is CenterLine SST Series P or Series EP cold spray system, and below that is our approved cold spray aluminum powder, SST-A5001. Now, for those of you in our audience who require specifications in order to utilize a repair process, you can count on us to help you develop that internal specification. Okay, let's assume for a second that you're wanting to work with us to evaluate the repair or remanufacturing one of your components. What are the next steps? Well, in most cases, customers will send us a sample and or a description of the component that they're wanting to remanufacture or consider for remanufacture. CenterLine's SST staff members will quickly provide you with a full technical and commercial analysis. Then we're going to indicate to you whether or not your component is repairable using the SST cold spray technology. If it is, we'll coat the sample part for you, return it back to you for your evaluation, and continue with discussions with our technical and commercial staff. It's very easy to contact us. I've provided you with a toll-free number at the top of the contact information there. Our email address is info@centrline.com. Anything having to do with cold spray comes directly to me. If there are any of you out there that have yet to visit our website, I've got the website address up there for you and a copy of my business card. I'm going to leave it up there for a while. Now, while I leave this information posted, I'm going to answer some of your questions.
Okay, thank you, Ed, for that presentation. This is Mark again. We're going to move on to the Q&A segment of our program now. Just a reminder, if you haven't placed your question yet, please use the resource widget at the bottom to do so. We do have a fair number of questions today, so we will do our best to answer all of them. For those of you who, for those that we cannot get to, we will be posting a written response to the resource widget after the webinar. It'll probably take us a day or so to get to that, but all of the questions that have been posted today will be answered either through this session or afterwards on the resource widget. So Ed, let's get started with the first question. How do you make good adhesion of your coating with substrate?
Thanks, Mark. One of the important things in designing a solution in any coating application is proper surface preparation. Our coatings training teaches us that about 90% of our resources in formulating a coating solution actually starts with surface preparation. Now, we know that by blasting with various types of media at various angles and pressures, we can affect the morphology of the substrate before the coating is applied, and that's one way to optimize adhesion. Certainly, starting with a standard metal, there's a world of additives out there that we can use to help increase adhesion to substrate. It's fairly specific depending on what type of coating and what type of performance you're looking for, but that's generally how we go about making adhesion, and we've already got a database of hundreds of combinations of coating substrate from which we can start.
Perfect, thank you. Next question. Do I need to perform cold spray in a spray booth?
You need some sort of environmental controls when using cold spray. It's not unlike a lot of other metal coatings or even organic coatings where you require either a spray booth or some sort of cabinet. And why is that with cold spray? Well, even in the best of chemistry and the best of metallurgical formulations, there's still going to be some fugitive particles that don't adhere to the surface. So they're going to be collected in an environmentally controlled area, whether it's a cabinet or a booth, and they're going to be treated accordingly. So yes, you have to use a spray booth or cabinet.
Okay, thank you. Next question. What resources, recommendations do you have for analyzing areas reworked with this method that may have stress considerations?
What we've done is basically taken components that are, let's call them perfect, and take a component that's either damaged or worn or, towards the end of its apparent service life. And what we'll do is we'll do the surface preparation, we'll do the coating, and we'll do whatever finishing requirements the customer has. Then by working with some of our either our internal resources here at CenterLine, which are quite comprehensive, or with some of our institutional partners, some of the universities or research labs around North America, we'll take that finished cold sprayed part through all kinds of mechanical, metallurgical, stress, hot, cold cycling, and we'll do some FEA or some mechanical analysis comparing the repaired component to the original component. And that, because we have processes already established, and these institutions do it not just for CenterLine but for a wide range of industrial customers, we already have some well-established processes for validation.
Okay, great. Can you cold spray stellite cobalt-based material?
Stellite cobalt-based material is a very, very hard material, and the rule of thumb in general is the harder the material, the lower deposition efficiencies we achieve. Now, with the Series EP that we mentioned earlier in our presentation, we do have some abilities to spray harder materials. I think at this stage it's a little bit of a stretch for us to consider a straight stellite cobalt application with, relatively good performance. I'm talking now about actual production performance parameters. I'd certainly like to talk to the customer more about specific application, but I'm thinking just off the top of my head that may still fall into the thermal spray category, Mark.
Okay. One other question. It was mentioned during the webinar that the part does not need to be masked prior to spraying. How do you mitigate overspray?
As far as the world of coatings is concerned, where you have a liquid particle like an organic paint or coating like a polyurethane or epoxy, or you have a melted or semi-melted particle like there is in thermal spray, those particles, if they miss the target, they will adhere to anything that's off target. And then they'll solidify either by a curing process or strictly by cooling down. In cold spray, the powder is never melted. It never sees a phase change. It always remains as a solid particle. For all intents and purposes, there is no overspray in cold spray. If that particle does not adhere to target, it's simply going to bounce off of any other wall or obstruction in the component, and it's going to be collected in the airstream collecting the particles. So that's the reason why you don't need to mask. Now, in some cases, for customers who have very, very finite surfaces, they may want to mask just to protect it from a particle maybe coming into contact with that surface. But for most industrial applications, you don't need to mask. You're going to have a well-defined line between coated and non-coated surface.
Okay. Another question. Is nitrogen dioxide gas the only gas used? Can one use helium or argon?
The systems are designed to handle any propellant gas, from compressed air, nitrogen, bulk or bottled nitrogen. We've sprayed a lot with helium. We've got one customer who's spraying in a nuclear environment where he needs to accomplish quite a bit of coating in a relatively small amount of time. So the specification that he's choosing for that application on our equipment is helium as propellant gas. Sure, you can use argon as another inert gas choice. It just boils down to what's the density of the gas, i.e., what can I accomplish as far as productivity versus cost. But there's no restriction on the type of gas we can use.
Okay, good. Thank you. Next question. How thick can the coating be applied?
That's a good question. It's an interesting question. I want to be really specific with this answer. There's no upper limit to the thickness of a cold spray coating. And when I say that, you can apply other types of coatings, such as let's use polyurethane coatings as an example. They cure very, very quickly. So theoretically, I could build quite a thick coating. But once you start building a traditional coating to a vast thickness, you get into a situation with heat management. You've got an exothermic reaction with a lot of these coatings, and that actually impresses some stresses within the coating. So the beginning of the coating application versus the end of the coating application, the chemistry may change because the cure cycle is changing. With cold spray, whether I spray 20 mils, 200 mils, or 2,000 mils, it doesn't matter. The coating chemistry and the physical properties of the coating is consistent through the beginning to the end. So there's no upper limit on the thickness of a coating with all practical intents and purposes.
Great. Okay, thank you. Next question. Is the cold spray coating gas permeable?
Good question. From a physics point of view, I could almost unequivocally say that almost every coating is permeable to gas travel. It's just what's the speed that gas is traveling across the coating. Let's just talk this through. Let's think this through. Our coatings are very, very dense, typically less than 0.5% porosity, volume on volume. But if we choose to, we can drop that porosity with some parameter control to less than 0.1. And I think we've designed some coatings with some special materials approaching 100% densification. That's going to provide customers with a fairly impermeable barrier coating between, let's say, the cargo and the vessel wall. That's typically where permeability or a sealing, S-E-A-L-I-N-G, a seal application where permeability is very, very important. Let's do this. If there's a customer there with a specific application, he's probably testing that leak with helium or hydrogen as the permeability gas test media. So I'd invite the customer to work with us. It's easy for us to design experiments to check permeability for his specific application.
Good, thanks. We have another question here from someone who's indicating that we occasionally must weld repair large parts that have previously been hot dip galvanized. We could repair the galvanizing with thermal spray. Is cold spray a candidate for this repair?
Another excellent question. Cold spray is actually an excellent candidate to substitute for galvanized, hot-dipped galvanized processes. From an economical point of view, hot-dip galvanized is fairly economical. In other words, you can hot-dip some very large pieces and coat quite a large surface area per dip, depending on the mechanical configuration of the parts, etc. And most engineers actually design parts with certain gas escape ways, bleeder lines, etc., so that it optimizes the galvanized coating. However, if you're doing post-operations on your galvanized part, if you're welding, if you have damage, if you lost some of the galvanized coating, it is so easy to use the SST equipment. You would simply blast, using 80 grit blast media, you'd simply blast the defective area and reapply a pure zinc coating back on the surface. Mark, it's just as easy as that to repair galvanized surfaces.
Okay. Here's an interesting question. Are decorative finishes an option for this process?
Decorative finishes. I've got one customer who's using cold spray to apply metals such as aluminum, zinc. He uses zinc and copper onto glass surfaces. Now he's got one main industrial application for which he's applying the cold sprayed bus bars onto glass. However, he's got a few applications where he applies the coating, the cold spray coating, in a robotic design, and then polishes these coatings to a very shiny surface. So he's actually using it as a decorative emblem application technique, where in the past he was probably using a silk screen technology. So certain circumstances, it does make for a beautiful aesthetic design coating.
Oh, good. Okay, I have to mention that we have a very strong audience here. It seems every question you answer, we get 3 or 4 that are submitted. So
I hope I'm answering them all right.
Well, yeah, I'm sure you are. Okay, another question. In slide 22, there is a photo of a bucket blade. How long does it take to coat the dovetail of this blade?
That's a very good question. The customer has set up a robotic application here, so he's repetitively doing dozens of these turbine blade root repairs on program, and it's probably safe to say that each one of those dovetail repairs is taking under a minute. And I would say that that's probably including the transportation of the part in, surface prep, coating. It's probably 1 or 2 passes, and then removing the part. So I would say, you know, I'm guessing it's under a minute per part.
Okay, good, thank you. Next question. What corrosive resistance does the cold spray have? Is it similar to stainless steel or Hastelloy? I hope I'm pronouncing that right.
Yeah, Hastelloy, stainless steel, Inconels. These are all, nickel super alloys that are used in chemical, nuclear, industrial applications where a couple things, corrosion resistance and durability, mechanical durability, are designed into the materials. I hope the audience can appreciate that the corrosion resistance of the surface that's resultant from cold spray coating is fully dependent on the coating material that you start with, the choices that you use. What can SST cold spray currently spray? Well, stainless steel 304, 316 is quite common now for us to apply those as corrosion resistance barrier coatings, etc. We can spray Inconels. Our Series EP running on helium can spray some of the harder materials for corrosion resistance. It's the most common application that we have. Several specifications are out in the marketplace right now where cold spray is providing corrosion resistance to the most corrodable metal on Earth, which is magnesium, and that combination is typically aluminum coating over magnesium for corrosion resistance. Now, all of these can be tested using standard ASTM corrosion test methods, so each application's same. It's really dependent on the coating material that you choose.
Okay, good, thank you. What is the thinnest coating that can be applied? What is the metal particle size?
Good. This question comes up. Quite a bit. Now, I want to stress to our audience members, our particle size that we start off in our raw material that we're propelling towards the surface. It's typically, anywhere between 10 and 60 microns, depending on the material, its apparent density, etc. The size of those particles doesn't exactly correlate to the thickness of coating, or let's say to the thinness of the coating that you can apply. We've got a customer right now who's successfully applying a very thin coating of tin over copper as a replacement for tin plating. And most of our customers know that plating is a very slow process that applies very thin metallic coatings to other substrates, but it's very uniform and it's got some very, very good properties. That customer that I mentioned earlier is applying 30 microns with a nice, continuous, consistent coating. So I would say that's pretty well our lower limit mark, is around that 30 micron, just over a mil coating thickness.
Okay, great, thank you. Okay, next question. Must the angle of the spray be 90 degrees at all times to the surface?
Not necessarily. Of course, we've done so many studies on this because CenterLine over the past 10 years have gotten requests to cold spray parts or components that are in areas that may be extremely challenging to access, accessibility issues. So we have to design 90-degree nozzles or 70-degree nozzles. Here's the rule of thumb that we know for sure. We prefer that the customer spray 90 degrees perpendicular to the surface. You can vary that by 10 degrees off perpendicularity, so plus or minus 10 degrees. You can go further. You can go further off perpendicularity than 10 degrees, but you start losing your efficiency as far as the number of particles that are participating in the coating versus the number of particles that you're spraying. The coating itself is, for all intents and purposes, is mechanically as good as the coating where you have a 90-degree angle, but you're losing some of your productivity. below 45 degrees, I would say that you should probably look at alternate ways to apply the coating, but we prefer 90 plus or minus 10.
Okay. Here's an interesting question. Is there a coating that could be used in auto body, or is there a coating that could be used in auto body repair instead of Bondo type products? Would it be cost effective?
You know, we had our very first markets that we looked at 10 years ago had to do with all metal repairs for high value or vintage automotive body applications, as opposed to engine or crankshafts or, you know, some of the underbody, some of the structural components of cars that we would repair, pitting and corrosion. But what about the actual body itself? A few things have changed since then. You know, I've got to admit that the chemistry, the polyester chemistry used in Bondo repairs for automotive has really, really improved, especially over the last 10 years as far as performance, environmental compliance, etc. Yes, we can definitely apply metal coatings to body panels and finish them to the point where we could coat over them with Class A finishes. So the answer is yes. But I would say the actual application and the finishing time is probably not as competitive as some of the best organic body filler type materials out there today.
Okay, thank you. Another very interesting question. Can this process be applied to 3D printing technology?
3D printing technology, let's think about that for just a minute here. Cold spray is an additive manufacturing process in a way. We're adding materials to substrate. So for a 3D printing application, the customer basically wants to design a finished part based on the addition of materials as opposed to the removal, right? The removal of materials through a machining process. If you had enough controls on the rotation, orientation, and especially the feed rate, you probably could eventually get to a manufactured part. I would say that control rate now is probably beyond typical cold spray applications. However, CenterLine recently designed some what I would call particle stream interruption technology, where we're working with one customer to design some fairly intricate flat patterns. I would say if the customer wants to work with us on, it's mostly mechanical, Mark. It's got really very little to, the understanding of cold spray. It has to do with control of gas, powder flow onto a specific substrate at a specific time. So yes, we could. Typically, that's done with a very finite technology like lasers, etc.
Okay. Okay. Let's see. I just lost the one question here. Sorry. How closely can the spray material's tensile strength be matched to the base material? I'm thinking of 4140 or 4340 steel.
Good question. Remember that we're basically, what we're doing is we can start with a raw material that's of the same chemistry as the substrate. So if the customer's got a 4140, 4130, 4000 series material, we can probably get that powder on the market or have that powder manufactured for us. Now, cold spray is an iterative process where we're constantly deforming these very, very small particles onto the substrate and then onto themselves to build up a coating. The tensile strength, when we pull tensile bond strengths, typically evaluated using ASTM C633, the same method for thermal spray coatings, we're typically going to get between 6,000 to 10,000 psi. So that's not near the tensile strengths of typically the wrought materials, which are in the tens of thousands of tensile psis. I don't think there is a coating process that can achieve the same tensiles unless you get pure metallurgical bonds like a welding or something in that nature. So typically metal coatings themselves in the thermal spray category will get, Mark, I'm going to say anywhere between 20 and 30% of the raw material's tensile strength.
Okay, good. Okay, here's a very specific question. A 356 aluminum horizontal engine main bearing bore out of tolerance. Is compressive strength of cold spray adequate for build-up to prep for lone hone?
Excellent. One of the best features of cold spray coatings is its ability to hold compressive forces. I mentioned earlier that we can design some well-adhered, highly densified coatings, sometimes with less than 0.1% porosity. That's a volume-on-volume basis when we assess that porosity. Compressive forces are held extremely well with cold spray coatings. We've got plenty of customers who are using cold spray coatings in weight-bearing or force-bearing situations, and the 356 alloy is a perfect example where cold spray application would be very well suited for that repair.
Okay, great. Next question. Can cold spray be used in a welding type of situation?
Well, that's a simple question. The answer is no. Cold spray does not have the same degree of metallurgical bonding that welding does. And of course, in welding, you're going through some very serious heat and phase changes to get toward that metallurgical bond. For example, welding, I can put two flat pieces of steel, butt joint them together, and weld together some web material that may be used in a structural beam or a bridge. So I'm actually joining those two structural materials with a weld bond. Just to be clear, cold spray is not meant to be used as a structural weld bonding of two structural materials.
Okay. Next question. How fast does the spray harden, or is it ready to be machined?
There is no cure for cold spray coatings. We don't have to wait for any chemical reaction, and we don't have to wait for any thermal cooling or reactions at all. The moment you're finished cold spraying is the moment that you can finish the part, or if you're not finishing the part, the moment that the cold spray process is finished, your part is ready to go.
Okay, good. Next question. Have you ever used it to repair crankshafts that are used in locomotives?
Locomotive crankshafts, the way I view that is, basically the same criteria that I would look at a, automotive engine crankshaft, camshaft, engine components, etc. It's larger. It's probably subjected to, to some more force, probably a little more, abuse, etc. Sure, depending on the degree of wear or the defect, the damage, maybe a component has been over-machined, maybe it's the journal areas that need to be coated and refinished. Sure, we can look at any type of engine component repair. We've got several existing customers right now using our cold spray equipment to remanufacture components that go into 16-cylinder diesel engine power backup supply. These are huge engines the size of a medium-sized car, and customers approach us for either coatings or application parameters to repair any of those components that go in there. Can we repair every single component inside those? No, but there's a good selection of components. I definitely look at that crankshaft. I'd need to know where the defect is, but I'm interested in working with the customer on that application.
Okay. Here's more of a operational question. How long would it take to train my staff to use this process?
Typically, when we sell and commission an SST system at a customer location, we provide the customer with up to 3 days access to our technician on site. Now, what that technician is doing, of course, he's setting up the equipment, he's working with the customers, electrical engineers, EH&S, but what we also provide is on-site training on how to operate the control unit, how to orient the gun, how to change over from the blast media to the coating materials. But I can tell you, if anyone, say for example, just wanted pure training on cold spray, they could come to our facility in Windsor, Ontario, and one day we could show them basically all there is to know, and especially about their own application. I would say one day, and there's no special certifications or institutional certifications required for cold spray.
Okay, thank you. Can the powder be reusable?
Once the powder leaves the cold spray gun, it's going to travel towards the target. It's going to hit the target, and it's either going to adhere or it's going to ricochet off the target and some cabinet or booth surfaces. Now, that particle has, a couple things have happened to that particle. It's changed its shape, so it's not the original shape as it was in the raw material that we started with. And it's probably also contaminated either with some of the substrate corroded materials. Probably it's been contaminated with some of the blast materials, and it may be contaminated along its pathway towards the dust collector, etc. It may have been contaminated with some oils or some materials from the environment. Can you recycle it? Yes, you can. It takes quite a bit of environmental controls, analysis, etc. It's usually not worth the effort to recycle it. The best method is probably to salvage the metal value from the powder and work with your recycler. But if you're using an extremely high value material like silver or tantalum, molybdenum, those types of materials, then yes, it may be worth considering a recycle approach.
Okay, thank you. We are getting close to the end of this webinar, so we only have time for maybe one or two more questions. I can tell the audience that we have about 70 unanswered questions still in the queue, so we will address those offline and post them to that resource widget as soon as we can. So the one more question I have for you, Ed, is can a cold spray surface be plasma sprayed over at a later date? Example, Metco 445 plasma sprayed over a cold sprayed repair area on a magnesium gearbox housing.
So what I'm hearing here, Mark, is maybe a customer considering using cold spray as an intermediate coat. That's a good idea because cold spray has very, very good properties. You can move along at a fairly productive rate, and then you can either thermal spray, plasma sprays, this specific question, a material over the cold spray surface. Mm-hmm. I guess the rules are the same. So long as you treat that coating as if it was a substrate, in other words, is it well adhered to the original substrate? Is it clean? Is it free of oxides and contamination? So long as those properties are in the cold spray coating, I see no reason why you couldn't apply either another thermal spray coating, another cold spray coating, or an organic coating, a polyurethane, an epoxy, an alkyd, medium oil alkyd coating. So again, work with us on the specifics, but my answer to that question is, yeah, to me it appears like you could accomplish a two-coating system starting with cold spray and finishing off with a plasma spray coating.
Great. Thank you. Okay, I think that's all the time that we do have for today's webinar. Thank you so much to everyone that attended and for your very good and varied questions. We will, as I mentioned, answer the rest of the questions offline, and we'll be posting it to the Global Spec website as soon as we can. It'll likely be 1 or 2 days. And we appreciate very much your time taken to attend our webinar and for your interest in CenterLine and our SST cold spray. All the best.
Thank you, Mark. I'd like to thank all of our attendees for spending their valuable time with us. I'd also like to thank our partners at Global Spec and Mark Levesque for all the work that he did in presenting the webinar. We look forward to presenting the next one. Look for us online for our next webinar presentation. Thank you, and good afternoon.